Hi everybody. I totally missed being in class. I'm sorry I've been gone for so long. Could you get out a piece of paper and take some notes? Pause it if you need to. Say for example that I had 4/7 and I wanted to add to it 1/7. You know, there's something that I don't know if your teacher ever did this when they taught you to add fractions, but technically they say if you have the common denominator, you are allowed to just add the numerators. So, we shortchange this and we say we get 4 plus 1 equals 5, and the answer is 5/7. But I'm writing it like this on purpose because I want you to remember that something that looks like this can be taken backwards too, okay? So it can be taken backwards. So this is like a forwards arrow and a backwards arrow. And I think it's important to us when we try to take the derivative, say, of something that looks like this. So I'm looking at it now. I have a common denominator of x. And I just want you to know the title of these notes is when the denominator is just x. And so if you just see x in the denominator, you could say to yourself, well, that's a common denominator. And I want to turn this into like my fractions problem. This is 10 over x minus 3x over x. And as soon as you do that, hopefully you will have a clue on how to take the derivative of it. Because really 10 over x is the same thing as 10 to the times x to the negative 1 power. There's a hidden invisible 1 there, and it's in the denominator, so I can bring it up into the numerator, and now I should be able to use the power rule on it. Not only that, but this x over x, it disappears entirely, and so I just have a negative 3. And if I want to find the derivative of my function, I don't know why I put a parenthesis there, I have 10 times that power of negative 1, and x is going to be reduced by another power, so x to the negative 2 power is what I end up with. And then here, if I take the derivative of negative 3, well, I just get 0. At some point you get tired of writing these zeros. I totally get you, and you can just say that, hey, this is your answer. Although I am still asking you to practice this for me, would you? Y prime is negative 10 over x being squared. I really want to see this answer on a test for a while, just so that you remember what it looks like. You know what I mean? All right, so that was an example of how to break up the fraction. All right, that's how you break up the fraction. Now, what about this next one? Well, I just taught you that if you have just x in the denominator, you do have an option. And you could say to yourself, well, this is the same thing as x cubed over x, and this is the same thing as negative 9x over x. And this would simplify then. Each piece simplifies into ta-da, and that's pretty easy to take the derivative of, right? But you had another option too, and it doesn't matter to me if you noticed it. You could say that this is x times x minus 9, x squared minus 9, and that all of that is over x, and so these things disappear. Either way, it's cool for me. It's just that in some cases, like the one above, there was no factoring that could be done. So I would love to see you approach it this way, not as much that way. I mean, yes, when something is factorable, definitely look for it as a thing that could be done. But like I said, if it's just x in the denominator, can't we just break that fraction apart and then take the derivative of it? So, by the way, when I take the derivative of it, y prime equals 2x, and that's plus a 0. Very boring. Who knew that something that was this complicated could have such an easy derivative? All right, try this next one real quick. Pause the video. All right, you're back. So did you do x squared over x and a 2 over x? And did you realize this was just x plus 2 times x to the negative 1 power? And if you did, then great. We could take the derivative in the following way. Y prime equals 1 plus 2. Let me take a second and do it slow. 2 times x to the negative 2 power, which is going to be 1 plus 2 over x squared as my derivative. So hopefully you like that, all right?